Alright.
TOT. No, TOT, ATT.
1 p.m.
Another quadratic
Saturday,
family is the
whatever.
dreaded Vieta-Jumping.
Exactly.
In its most basic form, if you have a symmetric two-variable equation of the form pxy equals 0, Vieta-Jumping lets you generate a two regular. I don't know why it's in bold. So all this two regular multigraph thing means it's just like you can get one solution to the next to another one. There's like no other choices. So two regular just means you can go forwards or back. Yeah. I don't know what multi. Just forget this language here.
Bro, multigraph means that you can have like you can have a loop, or you can have like multiple edges between two vertices.
Okay, so if x0, y0 is a solution, there should be another solution of the form x0 something, and another solution of the form y0 something. I guess these are the two directions you can go.
Yeah.
One then often applies some monovariant or otherwise to try to show the resultant graph is a path acyclic, so in order to either classify all solutions or at least show that infinite. But I guess the main thing is you're transferring from one solution to another, yeah? And then something about the solutions means the process needs to terminate, or...
Yeah.
So how would we start this one? Maybe we can try to figure out what Vieta-Jumping is. So you have a squared plus b squared. We're trying to prove if it's an integer, so it's equal to k times ab plus 1, yeah?
Yeah. For an integer k.
For an integer k, yeah?
Yeah, that's here.
Okay, so we want some kind of polynomial equation.
Move all to one side.
Yeah, that's what I want. So you have a squared plus b squared minus kab minus k equals 0. Yeah? There's a quadratic equation. Well, we want to kind of view this equation as some sort of quadratic equation. So the roots of this quadratic equation are like... Well, is it a quadratic equation one variable or two variables? Oh, okay, well, if you have one variable, a squared minus kab plus b squared minus k equals 0, yeah? That's a quadratic equation in A, yeah? Wait, are there obvious solutions we should be subbing in? A equals 1, B equals 1?
Yeah.
Yeah. Yay.
Wow. A equals 1, B equals 1 is a solution, yeah?
Yeah.
I see. Okay. So then you take so maybe we should take b equals 1. So if b equals 1, you got a quadratic equation in A, right? Minus k. One minus k equals 0. Yeah? Okay. So this quadratic equation has a solution a equals 1, right? But it has another solution.
A equals 0.
I guess why it's Vieta-Jumping is because you can find the other solution without solving the equation. So the sum of the roots is k, and then one of the roots is 1. So the other root must be k minus 1. Alright, then we go to another root, k minus 1, 1. Yeah? Oh, I see what to do now, I think. Yeah, so you started the solution 1, 1, yeah?
Yeah.
You sub b equals 1, and then you use the quadratic to get your other solution to the quadratic. And now you're at the solution k minus 1, 1, yeah? Yeah, so I think what you can do next is you want the quadratic equation back. So you want to change the 1 now. Yeah? So you want the b to be back. And you want the a to be k minus 1. Yeah? Okay, so then you get k minus 1 squared minus k minus k times k minus 1 b, and then it's b squared. So this is the quadratic equation. Yeah? So that's just this thing with a equals k minus 1. Yeah?
K is just something.
K is the integer that this is. Okay. Okay, so we have a quadratic equation in B, yeah?
Yeah.
Okay. And we know 1 is a solution. Yeah?
Oh.
So if we want to get to a different solution, we don't want to use 1, yeah? So we jump to another solution.
Jumping.
So how do we jump? Well, we know the sum of the roots is k times k minus 1, right? Okay. So then we just take k times k minus 1 and minus 1. That's the other root.
Yeah.
So then we go k times k minus 1 minus 1. And that's the other root, yeah?
Why is k minus 1 a solution?
K minus 1, 1.
Yeah, why is it a solution?
Didn't we jump to that before?
Yeah.
Wait, how?
So this was the equation. It was this equation, right?
I think you gotta take the original equation.
The original equation.
Yeah.
But isn't b equals 1?
Okay, so yeah, we'll say b is 1. That solution is a equals 1, and yeah, the other solution is.
Nah, just take the original equation and start jumping.
Alright, I'm confused.
Like the original equation is still quadratic.
Oh, yeah.
So like you just do it. I think.
Oh, without setting b to be anything.
Yeah, you just don't worry about it. Don't worry about it. Okay. Let me see.
Oh, you mean you have like a formula for the jump?
Wait, let me do something first. I gotta check if I'm not tripping balls. Hold on.
So we got k minus 1 and 1, and then we went.
How do you get k minus?
Yeah, how do we get k minus? So we had this equation here, right? That's with b equals 1.
Oops. Yeah.
Is it? That's with b equals 1, right?
Yeah. Okay, yeah.
And then a equals 1 is a solution.
Oh, wait,
and the solutions add up to k.
Oh, k's, what's that equal to? Not the, okay. Yeah.
Oh, cause like the
Yeah.
quadratic sum. Yeah.
I guess that's why it's called Vieta
Yeah.
jump.
So that's like, that is the mechanism behind the jumping. But,
Oh, I get it.
What does it got to do with Vieta?
Because
Because
Vieta
you
says
use
like
Vietas.
sum of roots is k.
use Vietas to like get properties of the object.
I thought it was just because Vieta made it up.
Favorite activity.
No, like, okay, so like that's kind of like the process of like how you generate, but like proving things with like using Vieta jumping, there's like, how do you say it? Like it's like what
Wait, something
Just
feels.
prove it goes down.
Wait, something wrong? Is that, I said they add up to
Just
k.
make A the bigger one, you jump A,
Yeah.
hopefully it's small.
Yeah,
That's
you keep on making it smaller.
That's basically what you hope.
Yeah.
Ew.
So usually with Vieta jumping, it's like you prove that like some property of k via infinite descent or something. You assume like the minimal AB, minimal solution AB.
Wait, I'm kind of worried here. Wait, if the roots are the solutions are 1 and k minus 1, yeah?
Yeah.
Isn't this the product of them? Why is it not producting to the right thing?
What?
Did I do something wrong?
What? What do you mean?
Wait, is there something
They're trying
wrong?
to
So
put
if you sub b
stencil.
equals 1, right?
For what?
Then this is the equation in blue. Yeah. And the sum of the roots is k, right?
Yeah.
And 1 is one of the roots. So then the other root's k minus 1.
Yeah.
But then 1, why doesn't 1 times k minus 1 to be Why isn't
That
this?
just means K is 1.
Huh.
Wait, is 1 a root?
That just means K is 1 when B is 1.
Oh, okay. K depends on A and B.
Yeah.
Yeah.
Okay, that's annoying.
Oh.
Wait, let me do it. Hold on. I gotta do it.
I've done it so many times, but it's always just fun doing it again.
Hmm.
I'll do it.
I've never done this. I don't know what's happening.
Bro, just get like.
Okay, so basically we're trying to get to different solutions, and we're trying to find some kind of degenerating feature of this.
Okay, I feel like it's all good.
It's all good.
I don't know.
Communication.
I feel like it's all good.
Wait, what happened? So what are we doing?
Just like fix it.
Yeah, I tried doing this in the Philippines question, so I sort of know what's happened.
Wait, Michael, can't you fix that?
Oh,
Well, I guess if you, I don't know, just try to jump. Right? If you try to jump to this thing, you try to jump A. The roots sum to like KB.
yeah. Okay, B. Yeah.
Yeah, so you just gotta hope that, like,
Oh, okay. So this equation is probably better if you
so you jump
don't want to
to,
worry
like,
about K depending on A and B. Okay, so basically we're trying to get to different solutions, and we're trying to find some kind of degenerating feature of this.
Okay, I feel like it's all good.
It's all good.
I feel like it's all good.
Wait, what happened? So what are we
Can't you
doing?
just like fix it?
Yeah, I tried doing this in the Philippines question, so I sort of know what's happened.
Wait, Michael, can't you fix that?
Oh,
Well, I guess if you, I don't know, just try to jump. Right? If you try to jump to this thing, you try to jump A. The roots sum to like KB.
yeah. Okay, B. Yeah.
Yeah, so you just gotta hope that, like,
Oh, okay. So this equation is probably better if you
so you
don't
jump
want to
to,
worry
like,
about K depending on A and B.
yeah, you want to jump KB minus A.
So you have solutions A, comma B, yeah. And you're saying you want to jump to the other solution. So the sum of the roots is KB, and one of the root here is B. Sorry, the root here is A. So it's KB minus A.
Yeah.
So AB jumps to KB minus AB.
Okay.
Yeah.
Okay, so the problem with just doing that is, like, what does that even say, bro? That's gonna just say nothing. But what if it did say something? Because then, like, if you manage to get that, and you can do the same, then it sort of, like, makes the solution smaller by some metric.
Oh.
And then you can, like, jump, since B is now bigger than A, you can jump B, then you can jump A, and then you can jump B.
Oh. Oh, okay. So the solution, the A and B are symmetric, and unless they're equal, one of them's bigger. Is that what you're saying?
Yeah.
So like if A is bigger than B.
So if they're equal, well, I don't know if it jumps to anything to be honest. Can they be equal? I don't think so.
Well, they can be
Like if A equals B, then it's like 2A squared on A squared plus 1. Like that's probably not an integer most of the time.
Oh, you can just solve it.
That's not an integer. Except if A is 1.
Yeah.
Yeah. So
Okay, you don't have to worry about them being
now
equal.
we're logging. We were logging.
So we'll log A is not. We'll log A is greater than B.
Yeah.
Yeah.
Okay.
Yeah.
Yeah.
So you're saying you could show that this is now less than B?
Well, I hope we can do that. Well, KB minus A, I want to show it's less than B somehow.
Okay, so you want to say KB is less than A plus B.
So if KB was at least A plus B, then this thing would be like, this thing's KB times A, so it's like A plus B times A.
A squared
plus AB
plus AB
plus stuff.
plus A plus B.
Yeah, that's bigger than the thing that we claimed it was. Yeah.
So then the A squareds cancel. And so we're saying B squared is greater than AB plus A plus B. So A is bigger than B, right? So B squared is not bigger than AB.
Yeah. That's impossible. It's not possible. Actually, put it greater than or equal to. Because, like, it's... I think you might need it. I don't know. I'm not actually sure. I'm just being safe.
Okay.
But yeah, the point is that KB minus A is indeed less than
This
B.
is less than B now, yeah.
Well,
Hmm.
okay.
Oh, that must... Does that must work in general?
So then, once you have your new pad, now you jump B, and then you jump A, and then you jump... I don't know. But yeah, you just do the same thing but with B, and then like... And because you assumed A is greater than B, this time you assume B is greater than A.
Okay, so let's...
And then you jump again. Wow.
B is greater than A, and we have... Oh, it's symmetric in A and B.
Yeah.
So you get the same conclusion.
Yeah.
So you get B wait, we're jumping A now. So then it jumps to KA minus B. Yeah. Yeah, if B is bigger. So you can keep decreasing it.
Yeah. Until it becomes very small.
I guess the funny thing is that it seems to not be relevant to it being a square. It just feels unrelated.
I think to prove it's a square, you just sort of show that like the smallest solution, it's a square, and then like you induct. Because everything can jump down. So then you can jump up. Or something like that. I don't actually know how this goes, I'm just making sure.
Well, let us continue to make it up until the end. So all the solutions for which it's an integer can be jumped to some smallest solution.
Oh, okay.
It's gotta be like 1, 1 or something.
Well, they have to be different, do they? Or can they be the same?
Wait, oh crap.
Wait, when they jump down, can they be different?
What is the smallest solution?
Yeah, I don't understand.
I'm not sure. Wait, what about 2, 1? No. Wait, oh, no. Surely.
So is Ka minus B is obviously positive.
So if it was negative, then what would happen? Ka minus B. Okay, if it was negative, Ka minus B is less than or equal to 0. Ka is less than or equal to B, but that doesn't make sense.
Less than B squared, yeah.
Wait.
So K and B.
So if I have a solution of A,
Wait, so how does this terminate then? They have to terminate when it's equal. Is that what you're
That
saying?
means I can fix B.
I don't actually know.
And there are two solutions for A.
I don't know. What do I do?
Wait, so what do we prove? We proved every jump we take. So it's A comma B jumps to Ka minus like that, right?
Not really all the solutions, but it's like how you generate solution.
And if B is greater than A, then A comma B
Also, if you fix
jumps to
Yeah, if you
A
fix your
comma
but how can you
KB minus A. Yeah?
Because if you fix both,
And we showed that this is positive.
Wait.
This is positive.
and then there's gonna be another R.
Wait, why is it the other way? What the?
Okay, so it'll be 2 legs. Yeah, and then you
And they can
Wait, did I switch it around?
I'm so
Yeah,
confused. Wait,
because-
what?
because-
Oh, this is K.
What is gone? Oh,
KB minus A. Sorry, this is KA minus
bro,
B.
wait a minute. That's K.
You fix your UA, which will call,
KA minus B.
and then you fix your A.
Yeah, and then it'll work.
It's gonna be
Okay, so what happens in this case? Is it we can't reduce it when they're equal or something?
I don't know exactly what happens. I'm so
It's-
afraid that.
I like you consider a minimal solution, which for A and B, which we'll call
I'm
what should we call it? We'll call it X and Y. So X and Y is a solution. Okay, so for a
Or
given
minimal for M and N.
minimal M and N for a given K. We'll say for like we have a given K. Right?
Or we fix K.
We fix K, and then this is the minimal solution for that K.
Uh-huh.
And then we try jumping. We try jumping, and we say this works, but has to fail. And this is here's why. And then if it fails, like this is the only way.
Then it's a set.
Whatchamacallit? Oh no, like if it fails, it means you can't jump lower.
You can't, yeah.
And so we want.
How do you know it failed?
Because it's a minimal solution, you can't jump anymore.
Oh, so you know there is minimal, so you'll
Yeah.
start decreasing.
Yeah.
Each time.
This is gonna be.
So what stops this jump from working?
Oh.
Alright, so what about this process, guys, can fail? Let's have a look. So if A squared plus B squared equals KAB plus K, right?
Yeah.
And you fix the identity.
A squared KAB plus K, right?
Yeah.
And you fix the identity.
A squared
Yeah, but like in this case, what we're doing is we're considering a minimal of A.
plus B squared minus KAB minus K equals 0. Yeah? Yeah, so one thing we did was we picked
You can also log A.
we picked one thing to be bigger than the other, didn't we?
Yeah.
Like if we don't have a bigger one, does it fail?
What do you mean?
So like if A is bigger than B, right?
Yeah.
We pick A to be the one that we're jumping from.
Do we want to pick A?
Yeah, I think.
Yeah.
Then you get KB minus A B, yeah? So that jumps to something small.
Check.
Yeah, so you have to check. So it's like
Check KB minus.
So that's smaller, but but like the previous one was minimal solution. So like, in what case would that not work? Like, would this be bigger? It would either have to be bigger or be negative, or just not be an integer. Like those are your.
Alright, so is K? Can we check that KB minus A is less than B? Is it less than B?
If it was more than B,
What's the problem with being
Specifies Vieta-Jumping, like not just some. So you also want to use like you want to use your constant term as well.
If it's more, like we might not have made any progress.
if it's smaller than B, it's smaller than A. Because like.
Oh, yeah.
Okay. So we want to prove it's less than B so that we can also
So
jump
is that
B
just sort of
for
like
the next time we do it.
You
Yeah.
get more.
We just keep decreasing A, B, and then eventually it's like too
Yeah.
small.
Because if it doesn't change, then you can't do the next thing. You're just going back. So we're trying to prove KB minus A is less than B, right?
So then you
KB. So what if KB minus A is greater than or equal to B? So then K B times A. Wait, is this plus K is greater than or equal to A squared plus AB
Mechanical pencil user.
plus
I didn't even go to work.
You're a mechanical.
This is my
Yeah.
mom's.
Right, use the
A-
mini pencil.
imagine.
A on B plus
I can no
1.
longer use any.
This is supposed to equal A squared plus B
I'll
squared.
record the message.
A squared plus B squared equals that. Okay, A squared cancels and you get
How do you know
B squared greater than or equal to AB. Yeah, so this is not allowed, right? Okay.
It's a bit weird.
Yeah, so it seems to be like
Yeah, okay.
And then we should prove that this is still positive, yeah? It is still positive. So KB, if it's not positive, so if it's less than or equal to A, right? KB is less than A, then A squared plus B squared is less than or equal to A squared plus K.
Nothing is wrong.
Wait,
Huh?
if KB is less than equal to A, then it doesn't work, right? Then
A on B.
negative, right?
So if KB is less than or equal to A, then that means KBA is less than or equal to A squared.
Yeah, and then the other thing's like
A on B.
like not less than an integer.
Oh, is A bigger than B then?
Okay, cancels mine out.
A is bigger than B.
Okay, so that's where it could fail.
Wild.
Is it?
Well, we get B squared is less than or equal to A on B.
Now you
I'm not listening.
It's a bit late.
Right, something's not right. K minus B squared is negative.
Did you do the other Viennas? It's called Vieta-Jumping because you use both.
Well, I'm just worried that that's not positive.
A squared minus K is not positive.
Yeah.
That's what you want.
KB minus A is positive.
Oh, if it's positive, you can just keep going.
But don't you
Yeah,
want it
but
to be
you
negative?
want-
Yeah.
You want it to
So, like,
stop.
how
You want
do
it
you
to be negative. You want it to be
I
negative.
guess, okay, so if you could prove it's always positive, then I guess you're proving there's no solutions, right?
You're proving it's always positive.
But if you proved it was positive, then you're saying there's no solution.
Yeah.
I don't know. That's the one.
Because then it would just keep going.
Yeah.
Oh no, but it can't stay positive forever. Because you're going yeah.
Yeah, just do that, and then now you have to
Wait, did you prove that it wasn't negative?
I guess, I guess,
But like, you know how
wait, you can prove it is negative?
Wait, can you prove it isn't negative?
I don't think you can prove it's not negative.
Okay, then when is it negative?
You just assume
Yeah.
that the minimal solution does exist, and you show that that's either negative or zero. And it's
Alright.
not
So,
if it's not it stays in the star or something.
okay, so if you get KB minus A is negative, right?
Never back.
Less than or equal to 0. Then KB is less than or equal to A. Yeah? So here KBA minus A squared equals B squared minus K, yeah?
If you don't make them zero.
And this thing here is negative.
Oh wait, no, it's just this equals A squared plus B squared. B squared equals
Yeah, actually, if it's equal, then K is a square.
I did not do anything.
if KB minus A
I'll
equals
suspend it.
Like, if instead of going negative, it goes to 0, yeah? If it goes to 0, then K is a square.
goes to 0, it's a square.
Yeah. Because then K equals B squared.
Because people don't think
Okay. Wait, but what happens is negative?
Yeah, what happens is negative. So can it be negative? So K would have to be K would have to be bigger than B squared, right? Wait, so if KB is less than A, right? If KB is less than A, then K is bigger than B squared, right?
Wait, why is K bigger than B squared?
it's greater or equal.
Like, if this is true, right?
Because if because
B
if,
squared minus.
yeah,
Okay.
because if this is because this is negative, then this would happen.
But it seems we also had something else before.
Did I get
Wait, hold on. If we sub it in before. Wait, if we had A squared plus B squared equals KAB, right? Plus K. Yeah. And we're saying if KAB is less KB is
greater
less.
than or equal to B squared.
So this is less than or equal to KB is less than or equal to A, right? So this is A squared plus K. Yeah. Oh, it's the same thing. B squared is less than or equal to K. Wait, so we got up to the. It has to go negative, right?
It's negative or it's negative or zero. It's non-positive.
Yeah, it's negative or 0. If it's 0, then we're done, right? And then
Yeah.
K is a square.
Yeah.
So what happens if it's negative? If K is bigger than B squared, B squared minus K on A is
Yeah.
an integer.
Yeah, because our second solution is an integer, right? Solution b a prime, like a prime is equal to b squared minus k,
Yeah.
and then you just move a to the other side. A prime is equal to b squared minus k. If our other solutions are right, we get this and then we get this, so we know that this is an integer. So we can let k is equal to b squared plus ta for integer t. If t isn't zero, you get a pretty easy contradiction. Did you get a is greater or equal to b cubed yet or not?
Yeah, I got that.
Okay.
I can't say.
Yeah, and then you should so after doing k is equal to b squared plus ta, you should be done.
So this k is
B squared.
less than or equal to
Like
a on b. So b cubed is less than or equal to a.
Yeah.
Yeah.
Yeah. Also, yeah, and then we do the k squared. Also, yeah, k.
Oh wait. Yeah, hold on.
Yeah.
This thing here is less than b cubed, right?
Yeah.
But this thing has a multiple of a. B squared minus k equals a outside of k b minus a. Yeah.
I see how it is.
Is that what you're saying?
I see how it is.
That's basically.
So a is bigger than b cubed, right? So this thing here is bigger than b
Wait,
cubed.
but what if... Wait, b squared minus k, is that supposed to be positive?
It's supposed to be negative.
Is it positive?
Negative.
It's supposed to be negative.
Oh, hell no. Okay, then that doesn't work.
No, because we know that this here is an integer, and then we know that kb minus a is an integer, right? And then we know that since this is this can't be b cubed, right? This can't be like
with that attitude.
this can't be okay. This is less than b squared, which is it's less than k, right? Like the absolute value is less than k because like it's b squared minus k.
This thing here, yeah?
Yeah, absolute value is less than k.
This has absolute value less than k.
And we know k has like equal or less absolute value than a because it's like wait, do we?
Well, k is less than or equal to a.
Yeah. So it's like equal. So the absolute value of k, which is equal or less than a.
Oh, so we take absolute values, yeah?
Yeah.
So we take absolute values, we get
Yeah.
k minus b squared equals a times a minus kb, yeah?
Yeah.
Okay.
And
So
then
the
this,
absolute value of this, so this is less than k, right?
yeah, it's less than k, which is less or equal to a.
K is less than or equal to a.
Yeah. So we note that since this is like so we note this is greater than 0, right? It's between 0 and it's between 0 and a, but this is like a multiple of a, so it's a contradiction.
So it has to be 0.
So it has to be 0, or your k is b squared.
That makes sense.
Wait, so... Wait, what happens? So
So-
you take the absolute value, you get
Yeah.
K minus b squared is less than k,
listen, k,
Which
and
is
k is less than
less than
a.
a, because k is equal to a
Yeah.
times b.
But this is a multiple of a.
Yeah.
0.
Yeah, it has to be 0, and then since it's 0,
But b has to be 1 as well.
no, b doesn't have to be 1.
Yeah. Okay, but we're done now.